Hi, here we are then in another Wind Talk organized by the Basque Energy Cluster here at the Wind Europe exhibition and conference in Bilbao. And we are trying to get some insights on some trending topics of the wind sector from some experts. Today's title is Moving Towards Cost-Effective and Reliable Floating Solutions. And we have with us Jean-Daniel Lebon, Renewables Director from Freyssinet. Hi.
Hello.
And David Carrascosa, CTO of SAITEC Offshore Technologies.
Hello.
Hi. So, floating wind is, I think, a frontier for wind energy at the moment. The reasons I can think for for this are onshore resources being finite. We are running out of places to put on more wind turbines, and bottom fixed sites are often limited because of the coastal conditions. However, wind energy, we know, is very competitive economically, and the question arises, how competitive can a floating wind be, and how can we make it competitive like that? Would you like to comment on this?
Yeah, well, we at SAITEC are obviously strong believers in floating wind, in offshore wind. That's actually why we focus on developing, well, this new technology we have at the company, which we call SAF. We are strongly believers also in innovative solutions, in using, different approaches to what's being used to date, and we think that's the way we will be able to really reduce the cost to the levels that the market is asking. That's why we use concrete as main construction material, which provides, not only lower cost in terms of manufacturing when compared to steel solutions, but also local content and a lower need of specialized workers for everywhere you go in the world. And it's really the way forward. It's actually, if you move from fixed bottom offshore wind or onshore wind to what's floating, you actually, the barrier of sea depth limitation actually disappears, and you can make it global. So actually, responding to your question, one of the key drivers in how low the cost can be is, first is that this is actually a global market. So the supply chain can be developed everywhere, and I think it's really, the near future, the next big thing in energy to come.
Okay, thank you. You spoke about concrete. I think probably Jean-Daniel has something to say about concrete solutions.
Yeah, as David said, concrete is a cheap material and is available everywhere. And if there are a lot of projects today where the owner and the governments are very interested in developing the local content, they want to have renewable but built in their country by their people. So using concrete is the solution for that. And going back to your initial question about the cost of energy, what is very important for the next challenge for offshore wind, floating offshore wind, is to make it as cheap as possible. And as you said, onshore wind is very competitive, but there are limitations because territories there are already a lot of turbines, onshore turbines in plenty of territories. So going offshore is the solution. Bottom fixed has some issues as well, and the sea is big, so there are plenty of space to do that. But to achieve, to make floating offshore wind a success, it's got to be very well industrialized. And I think this is the challenge for the floater solutions that are coming into the market. So there are a lot of projects, a few projects coming today about pilot farms where you need to prototype the farm to make sure that you know how you're going to do it, going to embark into mass production. So it is very important that this be done now before you embark into mass production so that you can prove the methodology. And in that respect, concrete is also a good material because you can implement prefabrication techniques, and that's the solution to make it, if you want to produce one big floater, one every week, I don't see any other solution but using prefabrication, and concrete is a raw material for that.
Mm-hmm.
Yeah, I would like to add also, and I think we need to highlight that on that actually need of cost reduction, and well, why are we going deeper? Why don't we stay well close to the shore? It's obviously the great resource we have at great deep sites, both in Europe and in the US, Southeast Asia. So all those sites have the resource, but require, let's say, innovative technologies, innovative solutions to get the resource from there. So one driver is obviously the technology, the platform itself, but obviously the other driver is also the big turbines. The bigger we go, I mean, the less units, and well, that's a bit about how we will amortize actually the sizes of these big elements that we want to float out in the sea. So yeah.
Okay. Perhaps to understand the challenge in a more visual way,
Yeah.
It would be appropriate to speak about sizes and economic costs, especially relative to an onshore wind turbine. If we were going to put it on a floating platform, how big is that platform? How much does it cost? Where can we produce it?
Yeah, that obviously depends a lot on the technology, but I mean there are a few comparisons that have been done with the Tour Eiffel here in Bilbao, with the Iberdrola Tower. Well, what we did lastly was actually compare the size of our platform and the tower of a 12 megawatt wind turbine, which is actually to come. And well, the result is that the size of it is actually a football pitch. So an entire football pitch would be the platform with actually a wind turbine that is in the order of the 120, 130 meters tall, diameter of 220. We do actually have one of the blades that would be potentially installed in one of these turbines here in the exhibition, and actually the poster, which is real scale, go through, I mean, side to side the whole three in back in the Bilbao Exhibition Center. So I mean, that's the kind of sizes we are thinking about, and that's I mean, you may imagine how many problems you have to solve to make it possible, and that's something that is key. That's why the whole industry need to be built well just in the shore. We need to take into account the port facilities, and I think actually Jean Daniel can actually provide some insights on that. They've been studying on the industrialization of these kind of devices.
If you make a comparison, there have been a lot of marine structures offshore oil exploration platform. There's one in Canada which is about 130 meter in diameter, so which is, let's say, double the size of the SAT 10 megawatt platform. That took 4 years to build. So you can't build two platforms, two SAT platform in 4 years. So you need to produce one every week. So the way you approach the construction and how you integrate construction into the design is completely different. And that's the very, very big challenge, very important. And if you cannot achieve that, you cannot go into mass production. And as David mentioned, the turbines are getting bigger and bigger to reduce the LCOE, and the platform will tend to be the size of a football pitch. And you need to have new methodologies to be successful.
Okay. Lastly, I would like to ask you a question that touches my field a little bit. I work on wind turbine control, and it is notoriously difficult sometimes, depending on the platform solution, to control wind turbines that are floating. You are aware of these problems, and I suppose that there are design methods for the platforms that can limit these problems. Would you care to speak about this?
Yeah, well, I mean, Iker, you are the expert, but I mean, from our side, from the platform side, we've actually designed some elements as I mean, the plates we have attached to our hulls, so to actually take profit from the hydrodynamic damping effects. So these are those kind of elements you want for actually the turbine to move as low as possible. I mean, reduce movements and accelerations at the tower and at the nacelle level is essential. And actually, the wind turbine manufacturers understand the behavior of onshore wind turbines, bottom fix offshore wind turbines. Now we need to actually kind of produce something similar. We will have some larger movements and accelerations for sure, but actually somehow reduce that movement so they feel comfortable putting a turbine on top of our kind of platform. That's on the platform side, but I'm sure, because actually we've been collaborating and we've been having some great results with yourself, with Ikerlan, and I'm sure that you can also bring some insights on how we can reduce the movements and accelerations from the control strategy side.
Yes, clearly. The easiest would be to ask for a bigger platform and that moved less, and then it will be easier to control the turbines. But I think our job is to just operate them in a way that doesn't put any extra requirements on the platform, on top of all the implications of seaworthiness. And because I would say a ship usually goes to port when there is a big storm, right? These platforms have to stay on site. If they can survive that, they should be able to survive our control. That's our job. But I don't know what challenges are posed by, as I said, seaworthiness and the survivability of one of these platforms in a rough sea. They have to stay there all the time.
Yeah, they've been designed for that. It's the difference with a ship. A ship is not designed for that. I mean, if there's a big storm, the ship goes through the storm because you steer the ship. Here you cannot steer it, so the platform is designed for much stringent condition as compared to a ship, I believe.
Yeah, and I would add that there's a few structures on sea environment.
Yeah.
Don't you think so?
Yeah.
Very good.
And the beauty with the new generation of floating offshore wind platform is that if you have to maintain the turbine, you can tow it back to port, as compared to fixed bottom offshore wind,
Indeed.
which is a very big advantage, I believe.
Okay, thank you very much. I think that gave us a much clearer view of what floating wind is facing and how we can approach it. And I think we're running out of time, so thank you very much for
Thank you, Iker.
Thank you.
Thank you very much.